It's a pleasure now to bring back Carl Bass.
Thanks, Stuart. Whoa, it's loud. Okay, yes, this is a very paternal talk. I was just going to talk about, I want to talk about making for kids, because in some ways, the most special part of Maker Faire to me is just seeing all the parents with all the kids and the mutual inspiration that goes on. The kids inspiring the parents to do more, and the parents trying to motivate the kids. And one of the questions that always comes up is, how do you get started? So I just wanted to take a few minutes, talk about some projects I've made, talk about some projects I've made with my kids, then get to the question of, okay, so this looks all like a lot of fun, but how do I get started? And I'll try to save some time to answer a few questions. So I've been making things for a long time. Really hard. Okay. I've been making things for so long that my kids are starting to look like me. This is like 35 years ago I started making things. I didn't get started as young as some of the people in the audience here, but I got started when I was a teenager, started building stuff. One of the first things I built was this boat, so-called boat. That's me hanging off the back of it. But I think one of the things that's interesting about this boat, and it's interesting just about making, was this is about as makeshift a thing you could make as anything. So what it is made out, if you look carefully, there's those black tubes. Those are Army surplus pontoons that the US Army used in World War II. They would come to a river, they would take out a compressor, they would blow up the pontoons, they would lay them across the river, lay planks down, they would drive the trucks and tanks across, and then they would pick them up and deflate them and put them back in the truck. So in the 70s, 80s, a whole bunch of these were on the market. And so we figured if we took two of them and just lashed them together with 2x4s, we could go down rivers that we couldn't go down in our kayaks. And so we proceeded to do some incredibly stupid things, in this case, not in the making, but in the using of this thing. But like many things, one of the things people see all these finished projects, and in some ways they don't see all the early projects that come and all the failed attempts. We made ones that wrapped around rocks. We had all kinds of disasters. And half the fun of making is you make mistakes. You learn as you go, you do it better next time. And one of the things I would just like to say is nobody should be intimidated by seeing something on the internet, seeing something in a book and thinking, I can't make it that well. They didn't make it that well either. They got started, they made mistakes, and then it got better and better and got more refined. So here's one of many boats I then ended up building and designing, and I actually sailed them with kids in an outward bound program on the coast of Maine. So I built a lot of these boats, but really the first boat and what got me interested was just taking those big balloons and blowing them up and tying them together. Here's something I made, this is in the last 10 years. This is the first time I carved something out of stone. So I made this out of black granite. And it's a single piece that I turned into a bench. Called it the cheek-to-cheek bench, one, because it looks a little that way, and number two is when two people sit in it, they just slide together. But the important thing in the making of this thing was I didn't know how to carve stone when I started this thing. And I think there's another important lesson for kids is you just got to try. One of the things you have to do is just get started. I didn't know how to do this, and I figured it out as I went. And by the end of the project, I knew a ton more than I did at the beginning. And that's true about any scale project. It's almost if you don't know more at the end than you knew at the beginning, it's hardly worth doing. I mean, it's the essence of making and learning. Here's me in my shop. Mostly demonstrates I have an incredibly limited wardrobe. It also demonstrates that I've never found a piece of furniture that shouldn't be made with gigantic Acme threads. So this is my metal shop, and I've been building all this furniture out of old cast iron metal parts and then milling up wood and putting things together. But those were the things I made by myself, but then I started making things with my kids. And so this is a lot of years ago. This is a rocket ship that I built with my sons. And while at least the one you can see looks very happy, this started with the other one who's too tall in there, who's in the top of the nose cone there. And it was Jake's idea to build a rocket ship. And for weeks he talked about this rocket ship, and so I took him down to the shop, and we went to the lathe, and we turned this thing that looked a little bit like a baseball bat, but really was just this one solid piece of wood. And then we sanded and painted it, and we got done at the end of the day, and I was all excited with how great it had gone, and he loved what he was doing, I thought. When we got done, he just looked at me and said, "Dad, this isn't what I wanted. I wanted a rocket ship I could climb into." And so it was like, okay. So we then spent what started as a one-day project, turned into about a 4-month project of building this rocket ship. What's the coolest part in there is all the electronics in there. We found in a surplus aviation equipment store down by the Oakland airport. And so we just took all that stuff, including all those LEDs that are wired in binary. It has a little digital counter, and it was the kids' first encounter with binary math. So that was kind of fun. Here's another project I did with my son, Willie. He was the small one in the rocket ship. His head's bigger there. And I figured this was a good way to put stuff in his head. He made this little secret place where he hides stuff. It still sits on his desk. Here's the project. So this is Willie now. Willie was the little one in the rocket ship. He's now much bigger. And this is a go-kart that we brought in here last year. And it was interesting when you think about this and about the reason for making is someone asked me the other day, we were racing the go-kart around this parking lot down by the shop, and someone asked me, what's the biggest lesson Willie learned in making the go-kart? And I stepped back for a second, and I thought, one thing it could easily be is he learned how to weld. He learned a lot of technical skills. There's an electric, this go-kart, by the way, it goes about 55 miles an hour. It's an electric go-kart with a 20 horsepower motor on it. So one of the things was there's a lot of technical skills, how to program the controller, how to weld the thing together, how to bend metal. But really what I thought was the essence of what Willie took away from this was that he could come up with an idea and make it real. That he could go from just something in his head. By the way, I had never built a go-kart. I knew nothing about it. He knew nothing about it. It was just he had this idea, and he had the willingness just to say, okay, let's start. And we started out. We just laid out some, we looked online. It was kind of uninspiring. We went and we went in the shop. We took some chalk. We drew it out on the floor. We said, this looks interesting. Then we started designing it in the computer, and then we started building it. And I think that idea of you can make anything that's in your head is the most powerful idea there possibly is. It's just entirely up to your imagination. I think the second thing that I learned about it afterwards was there's something interesting in when you go from making things that are kind of for fun to where you're almost risking your life. So there is something like the thing with the head, it's cute. The rocket ship's cute, but that rocket ship doesn't fly. If you look at the go-kart, when you're going around turns at 50 miles an hour, you really begin to appreciate how well did I weld that thing on. How good was my design? So taking your own life, taking your life in your own hands with your own designs, that's one of those bridges you have to cross in designing and engineering and making things. Oh, here's a rendering of the finished go-kart. So let me move on to the next part of this, which is, okay, so how do you get started? And in some ways, I think you guys have done there it is. You guys have done what's really important in getting started, which is you're at a place like Maker Faire. So the question is, what do you do? And one of the biggest pieces of advice I could give is just get started. It doesn't matter. I was talking to a bunch of folks over at the Arduino booth, and they said, one of the biggest problems they have is people buy the Arduinos and they don't open them because they're afraid to ruin them. And you think, oh, that's terrible. It costs $12 for an Arduino or something like that today. Nothing's going to go wrong. Put it together, try something. If it fails, try again. But there's just this hurdle where I say, if you can just get started, you can remove the veil that it's such a difficult thing. Try it. Try the Blink program. Try to weld a piece of metal together. Cut something with a saw, nail it together. You'll try it, and then you'll figure out why you should learn more. And one of the best things about making that I see is kind of giving kids this just-in-time learning. So as opposed to, why should I learn thermodynamics? What's important about, what were they talking about? Inverse kinematics. It's not that motivating, but if I want to make that robot arm move, I need to learn that math. And so I think there's something about just get started, figure out what the problems are, and then all of this, usual school learning becomes a tool to solve a problem. So, how do you get started? Maker Faire is awesome. Can't imagine a better place to come than the Bay Area Maker Faire and look and see what's going on there. There are also lots of places around the area. So the Crucible in Oakland, if people don't know about it, classes, great for kids. Both my kids went through lots of classes there. Tech Shop, a little bit better for parents than kids. Hopefully it'll get better for kids. Do you guys know about instructables? People know about instructables. If you don't, website. People publish how they made stuff. And they publish everything from how to make a cupcake to how to make a thermonuclear device. Everything in between, robots, Arduinos, anything you want. And so it has a huge amount of projects up there that are totally worth seeing. So if you haven't seen Instructables, I hugely encourage you to go and look and see what's going on, because not only do people talk about what they make, they talk about the reason for why they made it. One of the coolest Instructables I ever saw was taking that idea of taking your life in your own hand to the limit. There's a video up on Instructables about a guy who basically makes this device that flies. But when it starts out, you just see him bending pipe. He's bending electric conduit that you'd buy at Orchard Supply. And he bends it all up, and then he puts a motor on it and a propeller, and it looks a little bit like one of those boats that goes through the Everglades. And then the next thing in the video, it cuts, and he's about 300 feet in the air. And you realize he's just bought all this stuff at Orchard, and he's flying 300 feet above the ground in this thing. So people do some incredible things. It's worth looking at. I'm not sure I recommend that one to everybody, but it's definitely worth looking at. One of the other things about getting information, I learned most of the stuff about making by going to the library. You guys are incredibly fortunate that the libraries are almost obsolete. You have, a vastly better library on the internet with, YouTube, and you can Google anything. It's amazing. I used to go there and wait for a magazine or find a book that was 20 years out of print. You can find instant information, and like I think Stuart said, one of the coolest things about the maker community is almost anyone will answer your questions. I have a whole bunch of Instructables up there where I've published, and and when someone asks a question, it comes to my email. And despite all my work email over here, if I see an Instructables email, it always jumps to the top, because I'm always excited about answering a question about something I care about. So I think that's generally true, and one of the great sources of sharing information in the maker community is people are really willing to share info. Let me just jump forward. Oh, well, one huge amount of hardware available. The Cricut is a great device if you guys haven't seen it. But what I would tell you about all these things is, in my mind, the most important step is just getting started. Just find something that excites you. It can be paper and glue, it can be scissors, it can be almost anything. The real trick is just jumping in, getting your hands dirty. Now, one of the things I hear all the time is people say, well, I'm not a maker. I say, what does that mean, you're not a maker? How do you know you're not a maker? And the way I always answer, I start with, well, have you ever cooked something? They say, yeah, I cook all the time. I say, well, that's a maker. Yeah, have you ever sewn anything? That's a maker. If you think about cooking, what do? Have an idea in your head? You start getting ingredients, you go through a process, you get a result, you try it out. If it's not good, next time you make it better. And really, that's the process of making. It's not more complicated than that. One of the awesome things these days is you can get access to almost everything, including professional and industrial grade tools online. So there's a lot of stuff you can get at Home Depot and a lot of stuff you can get other places. But if you go online, there are places like Makershed, but Fry's, McMaster, all of this stuff you can see the full range of stuff, all the way from the stuff you can get in the corner hardware store, all the way up to the most sophisticated stuff you'll need for almost any project. Let me just go forward to try to get you. This is I just want to talk about a couple people. This is my friend Emily Pilladin. She does this incredible job. She teaches a design and engineering course in a charter school in Berkeley. It's hands-on engineering, hands-on design. Summer, she teaches a summer program for girls, which is a fantastic camp. What I loved about the camp, I was helping out last year, and she had a whole bunch of girls, and this 10-year-old girl, at the end of the program, she said, "I've learned how to weld. What can I do?" And I think there is that sense of empowerment that comes from learning how to take these ideas and turn it into something real. Here's some work they did on a project. They needed a library in the Berkeley school system. There was not enough money. They did an online Kickstarter project, got $75,000 raised on Kickstarter for the school library for the Berkeley school. There's one of the first designs. I lied, I do have another t-shirt, but barely. This is them at my shop. After they did the design, they were cutting it out on the CNC router. Here's one of the elements of this X bookshelf. And then they built furniture, and an entire wall of the school library was made out of that single design, a modular design that they put together and raised all the money online to do it. And just like the girl who learned how to weld, the school needed a library, so they built it themselves. I think it's an incredibly powerful story. Let me talk about another one. This is Lexi Lewis. She's the granddaughter of an Apollo 13 engineer. She has this program called Inventing 101 that she's trying to get into the schools, and she's been working in a number of states to do that. Here's one of the devices she did. It looks like she did a little Tinkercad model up there. And this is a device to be used by firefighters. Oh, sorry. I don't know if I can go backwards. Somebody helped. Okay, so this is a device. What goes in it is a mask. So in case of a fire, you have a mask to keep out the gases, and they put it in this container, and the firefighters can throw it up to people in the building. This is another one of her inventions. The next one is she had read stories about the difficulty of getting kids to the clinics in Africa, and so she designed this movable platform that a mom can tie around the waist and transport the kids more easily. There's another great story here. Oh, there you can see it. Okay, I see Tony there. So this is the story of a bunch of kids who are outside. This is Tony Duros, his son Joseph, 7 other kids have built a pneumatically powered exosuit that is outside, and it's incredible to see the work they've done. Tony and his kids for how many years do you think, Tony? Have you been coming to Maker Faire with a crazy 8th year? So for 8 years, Tony's over there, and his son Joseph, this time he had worked with his older son on some other projects. This is a great one. It's out back of the Sequoia Pavilion. And you should see it. It's 8 kids from the Bay School, and they've worked on really interesting engineering problems. This morning I was talking to Tony about it, and what I loved about it, it doesn't work perfectly, and he'll be the first to tell you that as they started, it does some incredible things, but like I said, it didn't work perfectly, and probably the best thing about it is they're learning more as they go about the problem than they ever knew. There's a richness to the experience of learning and making that comes from only getting your hands dirty and actually trying to do it. There you can see Joseph in the suit, supported by his safety frame. Okay, another story about, there's Maha and Vernon Riley. kids who are doing 3D printing in the San Jose schools, and they've been going all over the Bay Area talking about it, doing a bunch of 3D printing. They came by this morning, and I think I have it here. Oh, there it is. There's the 3D print. So they've been doing it. They were in a math class. They were graphing things in 2 dimensions, got a little harder in 3 dimensions, trying to figure out how to do it. So they printed out these. I know I'm running out of time, so I'll try to finish quickly, and if there's any questions that we can't answer publicly, I'm happy to step to the side and answer any questions. This is one of the printers Autodesk has started making, so we just started making our own hardware. Not particularly, we're a software company, but we got interested in this idea of doing an open printer. And so what we did, here are the kids are, there's Riley and Maher, and this is the print. There they are with the printer. And the whole idea was that we wanted a printer that worked on open software. It was open hardware. We've just published the plans online with the full expectation that people take this and they hack it and they do more with it than what we've done with it. It's based on a DLP, but all the plans are up there. And we published all the specifications for the materials. Equally important thing in 3D printing is how do we push the material science, and so we wanted to make a platform so people could experiment with that as well. Okay, so what else can you do to help the kids? One thing is software. One of the things I'm most proud of in my day job at Autodesk is we've made all of the software for all of our professional products free for every student, for every educator, and for every institution in the world. And so if anybody wants software of any kind, you know, and this ranges from animation software, thanks. So animation software to mechanical engineering software to computational fluid dynamics, autodesk.com.students, and you get a 3-year license. When your 3-year license expires, you go back and you get another one. So feel free to go there. A couple other things. One product we've made really for making that really is from the idea of how do I conceive of something, how do I model something, all the way to how do I fabricate it is Fusion 360. It also is available for free, and it's a cloud-based product that is really set up around making things in groups of people that can easily collaborate together. There's also a bunch of free software for everybody. There's a 123D family, 123D Make, and 123D Design. Many of you may know Tinkercad, a web-based design program. One I've been having fun with is 123D Circuits. Helps you design simple circuits, things like Arduinos. It's a web-based program for doing electronics design, and it meshes with the other one so you can bring your electronics into your finished thing. Okay, last one I just want to talk about was Project Ignite. We're going to just introduce this project, which is, it's great to have the software, it's great to have all the online resources. This is really a program that we're launching for the teachers. We hear a lot of times, I have all the stuff, but I don't have the curriculum, I don't have the support, I don't know where to get all the materials that I need. And so this is a curriculum-based program that starts with project-based learning that's really available for teachers all over the world to use for the students to help them figure out how to make things. So there they are. Thanks.
Do you have time for a couple of questions?
Yeah, sure.
Yeah. If anybody wants to ask a question to Carl, please come up to the front mic here. Or if not,
If there are no questions.
I have a question, Carl.
Okay.
On the 3D printer,
Yeah.
the whole experience of going from being a software company to a hardware company, do you have any little war stories you want to share with us?
Yeah, you know, as hard as I said it is to make things personally, it's like 5 times harder to do it corporately. Like we made, all the mistakes you make are just bigger and more expensive, but it's that same process. It was actually hard. It's the first, in 30 years in business, it's the first time we've made hardware. And we definitely learned along the way, but I mean, you know, this whole process of making is one of being open-minded, confronting the problems, being open to finding them, confronting them, solving them. Every one of these problems can be solved. You just have to go about it. And so, you know, along the way, one of the interesting things, I'll just tell you the story. So we made this open thing. We wanted anyone to put in any materials they wanted to print. Seems like a great idea. Then we got all these reports of these cracking, almost exploding trays, because it just turned out that the material that we made the tray of and some of the materials out on the market, they reacted badly together. So, the more open you are, the more challenges you're going to run into, but it's certainly been worth it.
Life intervened.
Yes.
We have a question here.
Yeah.
Hi there. AutoCAD is an amazing piece of software, and it's great for doing design work, but there's a lack in the market of actually taking design work all the way through to actually talking to the instrument.
Right.
Are you guys headed anywhere so that you can go to like AutoCAD 360 and hit a print button and then actually have it go to your printers or anything?
Yeah, so
of that
one thing
nature?
we've done is we just brought out, we have a product like Mesh Mixer, which does that. There's Print Studio, which will take files from kind of any CAD program and turn them into printers. Fusion 360 is probably the most direct thing where you can have a program that you can design in, but fabrication is like kind of imagined from the beginning. So you can drive lasers, you can drive water jets, you can drive 3D printers directly. And that was the one that was most in mind of how do we go from design to making.
But does AutoCAD 360, does it support like actually connecting to your laser, connecting to your printer?
So some of
and then just,
them, some of them do directly and some go through Print Studio. So
Okay.
it puts it directly into Print Studio and then you can drive your printer directly from there.
Thank you.
You're welcome. Okay,
Well, oh wait, one more.
sure.
Hi. So helping kids make has gotten a lot more expensive since it was just giving them scrap lumber and hammers and nails. So how do you balance, or how do you recommend parents balance giving kids the tools they need with not spending their college education on all of the toys that are available
Who
at
needs
Maker
college?
Faire?
I think that's a great question, but you know what, in some ways, and the guys who were doing the big robots before said the same thing, money is not the answer to making these things. I mean, it really is this, creative process, and the more limited it is, sometimes the more inventive people are. And I would still say, start with pieces of paper, start with cardboard. There's also a huge amount of scrap around. If you go to the lumber yard, there's scraps there. The metal yards, in particular as the kids get bigger, you go and, you just ask nicely. And there's all kinds of stuff that's otherwise just thrown away that people are willing to share with you. You go to shops. I mean, I spend all my time trying to take my wood scraps and figure out who to give it to, most of the time I run it over to Emily's school, so I bring over these, big buckets of scraps and other stuff. But there are places out there, but I would not get hung up on the limitation because I think there really are really nice ways to get started. And even as they get to and the software is free, the information online is free. So I think there's a lot that can be done, on really limited budgets. The other place is these shared maker spaces, that are starting out everywhere. And things like, places like the Crucible, and I'm sure they're all around the Bay Area, but, the class of the Crucible, while not, inexpensive, they're in the $40 to $60. They're not dramatically cutting into college, but I would really just, go back to what I said at the beginning, which is just make a project, make anything, and make it out of whatever you have handy, and it'll grow.
So before making comes inspiration. So where do you get your inspiration from to create things?
Yeah, it definitely does. So places like this are great for inspiration. I mean, all I've been doing is going around taking pictures all morning and sending them to my kids and say, see this is why you should have got out of bed this morning. The younger one is suffering from, he had a high school prom last night. So he's very excited about what he saw, but he was also not willing to get up at 7 in the morning when I drove over here. I think online is great. I tend to follow a lot of people on Twitter who make interesting things. And so my Twitter stream is just filled with people making interesting stuff. There's a handful of online blogs and stuff like that also really point out interesting stuff. And that's probably where I get it. But, I also, I almost never refuse an opportunity to go see another inventor or artist studio and just go over there and see what they're doing. I always learn something, and hopefully I'm inspired to go make something else. Okay, thank you.
Thank you, Carl.